Application and calculation process for mode of grouped data. Welcome, everyone. Before we dive into today's lesson, let's take a moment to recap where we are in our journey through statistics. In our previous sessions, we worked on identifying the modal class, that specific interval in a frequency distribution that holds the highest frequency. We also introduced the mathematical formula used to calculate the precise mode for grouped data. Now, knowing the formula is one thing, but knowing how to use it accurately is another. In this subsection, I am going to provide you with a systematic, step-by-step guide. My goal is to show you exactly how to apply that formula to a real-world dataset so that you can move beyond just identifying a class and start finding the precise, exact modal value. The step-by-step procedure. Now that we have established what the modal class is and seen the formula itself on the previous slide, let's move into the practical application. Finding the mode of grouped data isn't just about plugging numbers into a formula. It requires a systematic approach. To ensure accuracy, we are going to follow a 4-step procedural guide. Let's start with step 1, identifying the modal class. Before you even touch your calculator, you need to look at your data table. Your first task is to scan the frequency column. That's the column that tells you how many times each interval occurs. You are looking for the single highest value in that column. Once you find that maximum frequency, look across to its corresponding class interval. This specific interval is what we designate as the modal class. It is important to remember that this interval serves as the home for our answer. The precise mode we are looking for is guaranteed to be located somewhere within this specific range. Step-by-step procedure continued. Now that we have successfully identified our modal class in step 1, we move on to step 2, which is all about gathering our ingredients. Think of this as extracting the specific variables we need from our frequency table to plug into our formula. There are 5 key values you need to carefully pull out. First, we have L, which represents the lower limit of that modal class we just found. Next, we need F sub 1, which is the frequency of the modal class itself. Then, we look at the neighbors. We need F sub 0, which is the frequency of the class immediately preceding or sitting above our modal class, and F sub 2, which is the frequency of the class immediately succeeding or sitting below the modal class. Finally, we need H, which is the class size. This is simply the difference between the upper and lower limits of any class interval in your table. Once you have these 5 values neatly listed, we proceed to step 3. This is where we perform the substitution. You will take those extracted values and insert them directly into our mode formula. The formula is written as mode equals L plus all over the denominator, F sub 1 minus F sub 0, divided by 2 times F sub 1 minus F sub 0 minus F sub 2, and then the whole fraction is multiplied by H. It might look a bit intimidating at first, but as we will see in the next slide, it is just a matter of following the order of operations. Step-by-step procedure continued. Now that we have our values extracted and plugged into the formula, we reach the final and most critical stage. Step 4, performing the arithmetic calculations. To avoid errors, you must follow the mathematical order of operations very strictly. First, focus on the top part of the fraction, the numerator. You need to calculate the difference between the frequency of the modal class and the frequency of the preceding class, which is F1 minus F0. Second, move to the bottom part, the denominator. Here, you will calculate 2 times F1 and then subtract both F0 and F2 from that value. Third, once you have those 2 single numbers, divide the numerator by the denominator to get a decimal or a simplified fraction. Fourth, take that resulting value and multiply it by the class size, which we call H. Finally, the very last step is to add this entire calculated amount to the lower limit, L. If you follow this sequence, subtraction, then denominator calculation, then division, then multiplication, and finally addition, you will arrive at the precise mode. Let's see this exact process in action with a real-world example on the next slide. Illustrative example. Imagine a scenario where a school health clinic has recorded the heights of 30 students in grade X to make this data manageable. They have organized it into a grouped frequency distribution table, which you can see on the screen. The first column shows the height intervals in centimeters, and the second column tells us the number of students, or the frequency, that fall into each specific height range. Our objective here is to apply the systematic procedure we just discussed to find the precise mode of these heights. To guide you through the calculation, I have provided a detailed solution breakdown. In the next few slides, we are going to walk through this step by step, starting with identifying the correct modal class and then extracting the necessary variables to plug into our formula. Now that we have reviewed the theoretical steps and the formula, let's put everything into practice with a concrete example. Solution breakdown, Step 1. Now that we have our dataset from the previous slide, let's begin the actual calculation by following our 4-step procedure. Step 1 is to identify the modal class. To do this, I want you to direct your attention to the frequency column in our table. Scan down those numbers and look for the largest value. As you can see, the highest frequency is 12. Now, look horizontally to the left to see which height interval that 12 belongs to. It corresponds to the interval starting at 160 and ending at 165. Therefore, we can officially conclude that our modal class is the 160 to 165 range. Keep this interval in mind, because in the next step, we are going to extract specific values from it to plug into our formula. Solution breakdown, Step 2. Now that we have successfully identified our modal class as 160 to 165 in the previous step, we move on to Step 2, which is extracting our required variables. Think of this as gathering all your ingredients before you start cooking the formula. Looking closely at our frequency table, we need to pull out 5 specific values. First, we identify L, which is the lower limit of our modal class. In this case, that value is 160. Next, we find F sub 1, which is the frequency of the modal class itself. Looking at our table, that is 12. Now, we need to look at the neighbors of our modal class. We need F sub 0, which is the frequency of the class immediately preceding or above our modal class. That value is 7. Then we need F sub 2, the frequency of the class immediately succeeding or below our modal class, which is 5. Finally, we calculate H, the class size. To find this, we take the difference between the upper and lower limits of our interval, so 165 minus 160, which gives us a class size of 5. Once we have these 5 pieces of data ready, we will be prepared to move to the next slide and substitute them into our main formula. Solution breakdown, Step 3. Now that we have successfully extracted all our necessary variables from the table, we move on to Step 3, which is the substitution phase. This is where we take those specific values we identified in the previous slide and plug them into our mode formula. Looking at the screen, you can see the formula in action. We start with the lower limit of our modal class, which is 160. Then, we add the result of a fraction multiplied by our class size, which is 5. Inside the numerator of that fraction, we have the frequency of the modal class, 12, minus the preceding frequency, 7. Moving to the denominator, we have 2 times the frequency of the modal class, which is 2 times 12, and then we subtract both the preceding frequency, 7, and the succeeding frequency, 5. It might look a bit complex at first glance, but remember, we are simply replacing the letters in the formula with the actual numbers from our height dataset. In the next slide, we will break this down step by step to find the final numerical answer. Solution breakdown, Step 4. Now that we have successfully substituted all our variables into the formula on the previous slide, let's move on to Step 4, which is the final calculation. This is where we perform the arithmetic to find our precise answer. First, let's focus on the fraction inside the parentheses. We'll start by simplifying the numerator. Subtracting 7 from 12 gives us 5. Next, let's look at the denominator. We take 2 times 12, which is 24, and then subtract 7 and 5. This leaves us with 12. Now, let's substitute these simplified values back into our equation. We have the lower limit of 160 plus the fraction of 5 over 12, all multiplied by our class size, which is 5. To keep things organized, let's multiply that fraction by the class size first. Multiplying 5 by 5 gives us 25, so our equation now looks like 160 plus 25 over 12. Next, we'll convert that fraction into a decimal to make the final value easier to interpret. 25 divided by 12 is approximately 2.083. Finally, we add this to our lower limit of 160. This gives us a final result of approximately 162.08 centimeters. As we move to the next slide, keep in mind that this value, 162.08, falls perfectly within our modal class of 160 to 165, which confirms our calculation is logically sound. Common mistakes to avoid. Now, before we wrap up our lesson, I want to pause and discuss some common pitfalls. Even if you understand the formula, it is very easy to make small errors that lead to the wrong final answer. Let's look at 4 specific mistakes to avoid. First, watch out for choosing the incorrect modal class. I often see students getting distracted by the middle frequency or perhaps the largest class interval. Remember, the modal class is strictly determined by the highest frequency. Always scan your frequency column first and identify the maximum value. That is your starting point. Second, be careful not to confuse F0 and F2. It is incredibly common to accidentally swap the preceding frequency, which is F0, with the succeeding frequency, which is F2. To keep this straight, just remember that F0 is the frequency located immediately above your modal class in the table, and F2 is the frequency located immediately below it. Third, make sure you are using the correct limit. When you begin your calculation, you must use the lower limit, represented by the letter L. For example, in our previous calculation, we used 160, not the upper limit of 165. Using the upper limit is a very frequent error. Finally, pay close attention to your order of operations during the arithmetic stage. You must complete the entire calculation within the parentheses and multiply that result by the class size, h, before you finally add the value to the lower limit, L. If you can avoid these 4 traps, you will be well on your way to mastering this process. Let's move on to our final summary of the key takeaways. Key takeaways. First and foremost, remember that identifying the modal class is the foundation of your entire calculation. As we saw in our step-by-step example with the student heights, if you misidentify which class has the highest frequency, every subsequent step, from extracting your variables to the final arithmetic, will be incorrect. Always double-check that frequency column first. Secondly, keep a close eye on your final result. The mode is a specific value that must fall within the boundaries of the modal class you identified. For instance, in our example, our modal class was 160 to 165, and our final answer of approximately 162.08 falls perfectly within that range. If you ever calculate a value that falls outside your modal class, stop immediately and recheck your arithmetic. Finally, try to understand the logic behind the formula itself. Rather than just memorizing symbols, realize that the formula is essentially a way to adjust the lower limit of the modal class. It uses the difference between the frequencies of the neighboring classes to shift that lower limit to a more precise point. To wrap up our lesson today, let's review the key takeaways to ensure you have a solid grasp of this process. If you follow these principles and maintain a systematic approach, you'll be able to master any grouped frequency distribution problem. Great job today!